We're given f of x comma y and asked to determine the partial derivative function values. First we have the partial derivative of f with respect to x at negative 1 comma 1. This would give us the slope of the tangent line on the surface in the x direction. Let's take a look at this before we find this value. The surface is graphed in blue, and this yellow plane is parallel to the x-axis, and notice how this tangent line is in that yellow plane, and therefore this is the tangent line to the surface in the x direction. So we'll be finding the slope of this red tangent line when we evaluate the partial derivative with respect to x. So to do this, we'll treat y as a constant and differentiate with respect to x. So we'll first find the partial derivative function with respect to x, and then we evaluate it at negative 1 comma 1. So the partial derivative with respect to x would be equal to the derivative of negative x to the fourth with respect to x, that would be negative 4x to the third, minus the derivative of 2x y to the third with respect to x. So we're treating y cubed as a constant. The derivative of 2x is 2, so we'd have minus 2y to the third. And then the derivative of y to the fifth with respect to x would be 0, again because y is a constant. So now we'll evaluate this at negative 1 comma 1. That would be negative 4 times negative 1 to the third minus 2 times 1 to the third. So this would be negative 4 times negative 1, that's positive 4, and then minus 2, which is equal to positive 2. So the slope of the tangent line on the surface, when x equals negative 1 and y equals 1 in the x direction, is positive 2. So go back to our graph just for a moment. Notice as we move in the positive x direction, we can see this tangent line is going uphill, and that's the reason why our partial derivative is positive. Now for the second example, we'll begin by finding the partial derivative with respect to y. So we're treating x as a constant and differentiating with respect to y. And therefore the derivative of negative x to the fourth would be 0, since we're treating x as a constant. And then we'd have minus the derivative of 2x y to the third with respect to y. Because the derivative of y to the third would be 3y squared, we'd have negative 2x times 3y squared, that'd be negative 6xy squared, plus the derivative of y to the fifth with respect to y, that would be 5y to the fourth. And now we'll evaluate this at negative 1 comma 1, so we'd have negative 6 times negative 1 times 1 squared plus 5 times 1 to the fourth. So here we'd have positive 6 plus 5, which is equal to 11. Which means at this point on the surface, the slope of the tangent line in the y direction is positive 11. This graph didn't turn out so well, but let's go ahead and take a look. Here it is. Notice how the yellow plane is parallel to the y-axis now, and the tangent line is in that plane. And as we go out along the positive y-axis here, notice how the tangent line is going up very quickly, and this tangent line has a slope of positive 11. I hope you found this helpful.